Okay, just making sure I'm gonna start recording. So, your quizzes, they still aren't done grading yet. You probably realized that. I've graded a few, but I'll get the rest of them graded hopefully by this Wednesday. And then you can, you know, look at that. And we'll talk about the quiz once I'm done grading all of them and I can see what the average is. But hopefully the quiz wasn't too bad last time. I think I talked to some of you after the quiz and it seemed like it was okay, but I don't know. For everyone in here, tell me how you thought the last quiz was in the chat or whatever. Okay, it's okay. Okay, we got. Okay, it looks like it was kind of on the challenging end. Okay, so I think I graded some of them like I don't know, it was on Friday or something. It was a while ago now, but when I graded some of them, I think most of you did pretty well, but I only graded I don't know, like 10 or so. All right, well, I'm gonna go over each of them individually, like I did for the past quiz, and then I'll, you know, hopefully, I know a lot of you when you first look at the quiz right away, because it grades automatically. It looks like you'll have a really bad score for a lot of you, to be honest, at first, but um, don't worry too much about that, because you probably did much better than the score shows. I just have to grade each of them individually, because Canvas doesn't do a great job of grading each question based off of the answer that I put in myself. Okay, so today we're gonna go over plotting again. We probably have 2 more classes on plotting. So we're gonna do that, and then I'll also have a class or 2 on importing data and then manipulating that data, because again, we need that for the project. So I've been going over more of this kind of specific details for the project over this past week and weekend. That's why I didn't finish grading your quizzes yet. And so yeah, I think we need to have a class or 2 kind of talking a little in depth about how to import data and then manipulate the data. So we're going to do that, and then I'll finally assign the project. So we're probably going to start the project a little later than I planned, but I mean that's okay. This is a flexible course where I don't have everything set in stone. I want to make sure that you all have everything that you need before we do the project. And initially, I was going to make the project on. Now I want to make it something interesting, right? So I was going to do it on basically climate change. I assume all of you have realized that that's real in the class, but if you don't, then you would have had to look at the data and plot it, and you would have to come to terms with that. But once I was kind of doing this project on my own, getting the data and then plotting it, and it's okay, but getting the data now, like from climate.gov, whether intentionally or not from this administration, not going to say it is, but it's kind of a huge pain in the ass really to get the data for temperature because I want data going from like 1900 to current day, something like that, and they really limit the amount of data that you can download in one go, and it's like we're talking about megabytes here, not gigabytes of data. All it is text. So it was extremely annoying, so I decided to change it from the project from climate change to instead something else that's still very relevant right now, and I think interesting to see. So we're gonna do it on COVID-19. So getting data for COVID is extremely easy. So I think we're gonna do that, and it's you know it's at least interesting to plot the data. Oof, I don't know if that's a good oof or a bad oof. I know it's not like uplifting data, but it's still interesting. So yeah, it's certainly not happy or anything, but kind of interesting. So yeah, so I'll give you the data myself. That'll be, of course, when I actually sign the project in a week or so. and it'll basically be a breakdown by country. So, I was doing some of this last night, and so I was basically plotting the amount of total cases, and of course you can see the US just above everyone, not a good thing. And then like Brazil, and then the UK, I think. Yeah, but it's interesting. So I think it'll be kind of a very relevant project to you, and hopefully it gives you some motivation to actually work on it. And then we'll also like do it by a breakdown for it by counties and by states. So yeah. Let's see, one more thing. Oh yeah. So for the project, I plan on, of course, teaching all of you the vast majority of what you're going to need to do the project, but some of it you're probably just going to have to research on your own for very specific things, for whether it's for doing kind of array addressing that we've talked about before, or to do some plotting things. So if you have a question, first you should Google it yourself. Because if you have a question on Matlab, there's a very high likelihood that someone has asked it on, on the Matlab forum before, or you can just go in the Discord and put it in there. So just for myself working on the project, I mean, I've had to look up some things to kind of figure it out. So, um, but also part of that is because, again, we're going to have a class or two on importing data and then kind of manipulating that data. And if you recall in one class recently, I said that we're going to use a function called read table to import our data, which is somewhat new. And it's not something that I learned before until now. So I've kind of been having to learn how to use tables, but tables are really good in MATLAB because we can have different data types within that table. So anyways, we're going to get to that later on, but are there any questions on the class in general or the kind of general plan for the project? I know I haven't had too many specifics, discussed about the project yet. And you'll probably have like 2 weeks to work on it, but I'm not totally set in stone on that yet. So no, you're going to do the project individually, but you can, of course, talk about the project with the class. And I would recommend using the Discord. I think most of you are in there, so that'll be a good place to kind of talk about it. Okay. All right, so then we're going to go ahead and get started again. So close out the chat here. Okay, so I didn't have a slide that I made for an example to kind of refresh our brain on how to plot. So I just made one right here. So basically we're going to plot that, what I have here in the editor window. So that's y equals 5 times e to the 0.2, or e to the negative 2.5x times cosine of 3x plus 7. And I want you to plot this function on a range from x equals 0 to 5. And then additionally, you should put a title, an x label, and a y label. So I'll give you a few minutes to do this. I don't want to take too long though, because I want to get over, or I want to kind of talk about a decent amount of stuff today so we can kind of progress. All right, so work on that. I'll give you a few minutes. Okay, so hopefully you at least got most of that done. But I'm gonna get started. So I'm in the editor window so we can save this file, and of course, just so we can press enter without Matlab, trying to run whatever code we just put in. So I'm gonna make this smaller. Okay, of course, I just deleted that, so I forgot what I have. Okay, there. Okay, so we need to plot this function on an x domain from x equals 0 to 5. So I'll first type in x equals 0. We'll do a step size of 0.01, then we'll go to 5. Then our function y, we're going to do 5. Then we have times e to the negative 2.5x, so I'll do times e. And then I have to raise it to I need to do the exponent like that. And then I have to do negative 2.5x times x. And I have to raise it to the power. Okay, let me go forward to my slides here to make sure that I'm doing this right. Because this is going to be similar to what we have later on. Okay. And then we're going to do times cosine of 3 times x plus 7, this should be 2 times x plus 7. I'm going to run this code and I'll save it. Okay, that ran okay. Okay, so we have 5. Okay, e to the negative 2.5x. It should be 5 times e. Sorry, I did that wrong. Okay. I run it now. Okay, that's fine. Okay, now we're going to plot this, plot x comma y, and then we'll have an x label, and we'll just say x label, whatever. Y label, y label. I just wanted to get practice for making an x label and a y label. And then we'll have title, yeah, okay. And then again, to run it, all I'm pressing is F5, that's a bit faster. And here's the plot. So there we go. Okay, so hopefully that kind of refreshes you on the plots that we're going to make. Okay, so the first new thing that we have today is plotting a single variable. So you can kind of think of this like we have some vector that's storing some data, and then we can plot that. So, this would be something like, I don't know, how much income you make per day or something. I don't know. How many steps you walked per day, something like that. So we have some vector that's storing some data, and then we can plot that and see how that's going to progress. So this is kind of giving you a random example for why you might want to do this sometime. So I'm going to make a comment. I'm actually going to use 2% signs here. I don't know if I talked about this before, but if I use 2% signs like that, then you see I kind of get this this block of this different kind of color here. So this is just a section inside of Matlab. So if you use 2% signs, you can make a section to kind of separate your code a bit better. And I'll call it plotting a single variable. Okay, so if we have some vector, I'm going to just make a random vector here. So let's say I have a vector, we'll call it v. And then again, I'm going to use the randy function inside of Matlab. So I'll have random numbers from 1 to 20, and the size that I want is going to be 1 by, let's say, we'll put it 1 to 20. Okay, so this line of code is just making a random vector that has integers from 1 to 20, and the size of this vector is going to be 1 by 20, so 1 row by 20 columns. Again, just kind of refresh on it. I'm going to comment all of this out just so we don't get that plot every time we run it. So I highlight everything here and then I press Control R. It might be different if you have a Mac, by the way. That kind of shortcut. Okay, so here's our random vector. I'll type it in the command window as well. I'm also going to add a top here, clear and then CLC, just so I can clear the command window every time I run the code. Okay, type in V, so this is our vector right here. So I just have random numbers from 1 to 20. Okay, so if I want to plot this now, I can do that. So all I have to do is plot, and then I'm just going to plot that vector. So I'll put plot, in this case, V. So here I only have one argument because I'm only plotting one vector. I can run that, and you see that this is my plot. Now, I only have, I guess, oh yeah, okay, 20. I only have 1 by 20. That's the vector that we have. So I only have 20 values here that are being used to make this graph. And this is kind of misleading, this graph we have here, because we have lines throughout. So by convention, you should use a solid line if you have a lot of data points. So that's when we have like a step size of 0.01 or something that's really small. Here we only have 20 data points, so it's kind of misleading to use the solid line because we don't have all of this data that's kind of being implied in this graph here. So what we're going to do, and we'll talk about this a bit later on in class, and I've done this kind of notation earlier on, throughout the class. But I'm going to put in apostrophes here. I'll do BO, and I'll also do a dash right there. So B, that stands for blue. O, that stands for a circle data marker. And then this dash right here, that stands for a line. So that's going to create this block for us. So we have blue line. We have circles. That's for each data point that we have. And then connecting all of our circles, we're going to use a line. Okay, so in this way we can do this. For our project, if you're doing like cases per day for some county, you could make a plot that's similar to this. We'd probably use like a bar plot instead, and we'll get to bar plots later on too. But that would be a way where we could see how many new cases we have per day. All right, plotting complex numbers. So we probably won't be doing this all too often, but who knows. I'm going to make a new section here, and I'm going to comment that out. Okay, so plotting a complex number, we can do this as well. So I don't know why I said if B is a complex number, because then I have the complex number down here as a Z, but who cares, that's fine. So if I have a complex number Z, and that's 0.1 plus 0.9i, I can make a plot for that. So let's do n. This will be our x domain. We'll do this time. Let's do linspace, and we'll do 0 to 10, and we'll keep it like that. So we only have 2 arguments for our linspace command. By default, that's going to give us 100 data points. Or I can add a third argument inside of linspace, and I can say 1,000. And now we have 1,000 data points inside of that variable, and we can see that in the workspace on the right. Okay, so now I can plot this. So I'm going to do plot, and I'll do Z, so our complex number, and I'm going to raise that to our kind of x domain here. So I'll do C to the n, and I have to do a dot, and then raise to the power, because we have a vector. We're raising this vector Z to a power. Okay, so if I plot this, then we get this nice little spiral. Okay, So I'm just going to quickly go over that one because I don't think, we're going to be doing complex plots all too often in our life. And if you are, well, then you can dig in on your own. Okay, plotting polynomials. I think we talked about this before. Or maybe I went over it, like skipped over it because I knew we were going to go over it in chapter 5. I think I did that actually. So, plotting polynomials. So we've made polynomials before. I just realized too, I don't need to keep commenting all of these out because if I make a new plot here, it's going to overwrite the plot that we had before. But who cares? Doesn't really matter. Okay, so we've made polynomials before. We've done that a lot in this class so far. That's just, making a vector basically. And each number inside of that vector is going to represent some coefficient inside of the polynomial. So we can make a plot for this polynomial as well. And this will be something that we do, actually somewhat often, especially when we're doing a least squared fit for some data that we have. You'll be using these functions that we're going to use right now, like polyfit and polyval. But we're not using polyfit right now, but we'll use polyval. So that'll be something that we do. And I think I actually might have you do something like this in a project as well, where you do a least squared fit for some data that we have for COVID. And then you can basically interpolate based on the current trend how many cases we might have by some future date. So that might be something that's kind of interesting to do. So, anyways, let's plot this polynomial here. So I'll have an x domain from 0 to 20. So I'll do x equals 0, step size of 0.01. We'll go to 20. And then our polynomial, so I'll just use a variable called p. And then I'll do 50, 25, 9. I'll just put what I have in this already. So this polynomial here that represents 50 times x to the third plus 20x squared plus 5x plus 9. And then we can plot this polynomial. So first, all we have right now is our x domain, so that's from 0 to 20. And we have our polynomial, which is, well, we just said 50x to the third plus 20x squared plus 5x plus 9. So that's fine, but if you remember, I think it's even in it's in our second slide, the two vectors that we want to plot, they have to be the same length. So right now, all we have is we have an x vector and we have a vector for the polynomial, but those are different, right? They're a different length. So I have to evaluate this polynomial that we have with our x domain to create a vector that's the same length. So to do that, we're going to use this polyval function. So again, that's going to evaluate our polynomial for this x domain that we have here. It might be kind of weird to kind of wrap your head around at first, but just think that we basically have our independent variable x, and we have our dependent variable f of x, which is our polynomial. So we're just evaluating that polynomial along that x domain. So if I type in polyval and then a parentheses, I can click on more help. And then we can see the documentation right here. And so there's quite a lot. So if you're a little confused on that, you can take a look at this. And here they have a linear fit. So this is what I was talking about just a few minutes ago for something that we might do for the project. Okay, so I'm going to use polyval again to evaluate our polynomial. So our first argument is going to be the polynomial that we're evaluating. So in this case, it's p. And then the second argument is going to be the x domain, or the domain that we want to evaluate the polynomial on. So if I type that in and I check out poly here, so let's do this. Okay, so if I look at our polynomial, that's called poly. Here it is right here. So that's what was that, from 0 to that's from 0 to 20 with a step size of 0.01. So we got quite a lot of values in here. So now our polynomial is evaluated on that x domain, and now it's the same length as our x domain. So now I can plot this polynomial. So we plot, we're going to put x, our x domain, and then poly, because that's our evaluated polynomial. And if we run it, and here's the plot. All right, any questions on plotting the polynomial?
So, Professor, when you put P into the polyval,
Okay, so again, that would be something that we most likely are going to do for the project. We're going to do a polyfit, so I'll talk about that some other time for the project. But we're going to be using this function here, polyval.
Okay.
Okay, subplots. So subplots, they can actually be useful sometimes. I don't use them too often, but let's say we're comparing data, like if we have multiple tests for something. So let's say we were recording the temperature of some object and we're doing that multiple times. So I can compare the temperature readings that we have for two different tests kind of side by side. So using a subplot, it's going to allow us to have, it's one figure, but it contains an array of plots. So let's do it like this. So you can kind of think, if I use the subplot command, I can have one figure here, which is highlighted, and it's going to contain an array of plots. So it'd be like one plot right here, one plot here, one plot here, one plot here, and so on. So you'll see what it looks like in just a second. But it basically allows us to already have some plots kind of side by side. Okay. And we might also use it if we're comparing data, the same data on different axis types. So maybe we want to plot data from some x domain of 0 to 10, and then we also want to plot it from 0 to 3 or something. So kind of, more constrained for one plot if there's something interesting to see within that range. So our syntax here is going to be subplot, and then we're going to have 3 arguments. So we're going to have subplot m, n, and p. So m, just like we've talked about for arrays, that's going to be the amount of rows that we want. N, that's going to be the amount of columns that we want. And p is going to be the pane that we want to have this plot on. So if I have subplot 3, 2, 5, that means we're going to have a subplot here that has 3 rows. So I'm going to have 3 rows and 2 columns. So in total, I'm going to have 6 plots here. Okay, I have 3 rows, 2 columns, that's 6 plots on one figure. And then this comma 5, that means I want this specific plot that I'm going to type out code for. That's going to be on the 5th pane. So you can think I'm starting out as 1, 2, 3, 4, 5. So 5, that's going to be the bottom left-hand corner of this kind of array of plots that we're making. So if I go back here again, you can kind of visualize this a bit better. So pretend all of these were highlighted in white. Here I have 3 rows and 2 columns. So in the top left here, there would be 1 plot. We'd have another plot here, another plot here, another plot here. And then here is the 5th plot that we have. So that's in the bottom left-hand corner. So this is the plot that we would get if we typed in subplot 3, 2, 5. All right, so we're going to do an example right now. You probably can't read that if you have a small screen. So I'll just type it out and you can follow along. So we're gonna do a subplot here where we have one row with two columns. So let's do our first figure. So we'll have x from 0 to 5. And then we'll have our function y here. That's e to the minus 1.2 times x. And then we're going to do times sine. And again, we're doing element by element multiplication here because we have two vectors. So times sine of 10 times x plus 15. And these are going to be some pretty cool plots, I gotta say. Okay, so we have our x domain and we have our function y. And so our first subplot here, we're going to put 1, 2, 1. Okay, so this is now telling Matlab that I'm about to make a plot here, and I want it to be part of a subplot. So I have subplot, and then 1, 2. So I have one row and two columns, and my last argument is a 1. So I want this this plot that I'm about to type out, I want that to be in the first pane. So kind of the first entry of our subplot. So now I'm going to actually make the plot. So plot x, y. And we're going to talk about colors later on as well. So I have x, y, and at the end that just stands for magenta. And then I'll do a line width of 2. So if I plot this right now, this is what we get. So Matlab knows that I said that I want to have a subplot here. All I have there right now is just one block. So we have that in this first pane right here. But because I didn't make the second plot yet, that's empty. So our second plot is going to show up over here once we get to that. But yeah, I think it's a pretty cool function. It looks like a damped RLC circuit. If you guys are, I think you go over that in 226. Maybe I just gave some of you PTSD, I don't know. But it looks cool. Okay, I also adjusted the axis. We talked about that last time, and then I have a legend. Maybe I'll add those, but let's make our second plot right now, just because that's the more important stuff. So we'll do x equals -5, the step size again of 0.01. Then we're going to go to 5. Then I'll do y equals 5 times x to the third. Again, we have our dot, because we are raising some vector to a power. Because of that, we have to do element by element exponentiation. And then times cosine of 5 times x squared. This would have been a good exercise for you to work on your own, but oh well. Maybe this will be a kind of a quiz question. I like this kind of problem here. We have plotting, we have subplotting, and we have element by element operations as well. Okay, and then I'll do subplot. So this time I still have to type in subplot 1, 2, because I want this to be on that subplot that we just created. So that's one row and two columns. And now the last entry that we have to fill in here is the second kind of entry. So we're going to put 2. Now if I run that code, this is what we get now. I gotta fix the axis, I guess, because there's nothing there. Oh, I didn't plot it. Maybe that's why. It'd be a good idea to plot it. Okay, so plot x, y. There we go. And we'll make it blue. And we'll do line width of 2 once again. There we go. Now we got a plot. Another pretty cool plot. Alright, so now we have two plots on our subplot. So in this first entry here, in this first kind of section, we have subplot 1, 2, so here we have one row we have 2 columns, and the first plot is going to be in the first pane right here. In our second section, we have our x domain, and then we have our function, and I have subplot 1, 2. Again, just to really nail it in the ground, we have 1 row, 2 columns, and for this, I want it to be on the second pane. So I put a comma 2 at the very end, and then we make the plot.
Professor,
Okay,
quick
any
question.
questions on subplots?
Yeah, for the first one, where'd you pull the variable from? Like the m and the b? Where did those come from?
Okay. So, hint, hint, I think this is going to be a good question for a quiz. So with subplots, it won't overwrite the previous plot. No, so in this case, yeah, we added another plot here, and it's not going to overwrite it only if you specify a different pane. So up here, I add the first pane, so I have a comma 1 at the end, and down here I have comma 2 to put in the second pane.
Professor,
Also, though, you'll notice that I defined x and y here. I also defined x and y here. So maybe this is more of your question, I'm not sure. But even though I'm using the same variables, I still have those 2 separate plots. So that still works because Matlab is basically, it does all of this right here. It makes that plot first, and it already gets the output. And then it's gonna run all of this code here. So even though I'm using the same variables here, I'm still getting both plots. And really, this what I'm doing here probably isn't the best practice. So we should probably do x2 and then y2. And then plot x2 and y2. And then that way we're not going to have any issues with our variables in the workspace.
Professor, quick question. Where did the m
Any
come
other
from?
questions on subplots?
Oh yeah, I have a question. Where did the variable m and the variable b come from?
All right, so now we're on.
I think you can hear you, man.
Can you guys hear me?
Professor, I think so one of the students is asking a question, but I don't think you can hear him. Is
Hello,
it
Professor?
Manuel? I think it is.
No, it's me. Professor,
Hello?
can you hear me?
Can you guys hear me or no?
I can hear you.
Okay. Maybe your sound just went out for a second. Yeah, I can't. If you guys are talking in your mic, I can't hear you. Oh, okay. Here, let me. Oh, okay. I see the issue.
One question about the subplots. Does the last digit notate position on the final
Remember, someone talk.
output?
So,
Okay, that's not.
It's so odd.
wow, this whole time I didn't have my mic plugged in. That's why.
Oh,
So it probably sounded worse than usual too.
Yeah, I was fainter.
Oh, okay. Well, yeah. Wish I noticed that. Yeah, my mic. It's my headphones and my mic are plugged into the same kind of amplifier. So yeah, that's why I didn't hear any of you too.
yeah. So, quick question.
Okay.
Where did the variables m and b come from?
M and B. Oh, so they're not variables, they're to specify the color. So if I ran this, then we have M, that's for magenta.
Oh, okay. Makes sense. All right, thank you.
Yeah. Man, I think I forgot to plug my mic one other time too. I don't know if that's for this class or another class, but oh well, I always forget.
I think it's the first time it happened here.
Oh, okay. Yeah, I didn't really notice yet there wasn't really any questions this time, at least for someone talking in the mic. Hopefully you weren't talking like the whole time and I was just, ignoring you.
I did have one question about the subplot command.
Yeah? Okay.
All right. So what denotates the position of the subplots in the display?
This last argument. So we have 1, 2 and this 1. That means the first kind of pane that we have.
All right.
And then down here, we still have to use subplot 1, 2 because I want this to be on the same subplot. So that's 1 row and 2 columns. And then comma 2, now it's going to put this plot on the second pane.
All right.
Okay. Any other questions? Okay. All right, so data markers and line types. So we've been using data markers and line types already in a few of our plots here, but I've never really talked about, at least in detail, what I was doing. So we were specifying our colors before, and in a plot earlier, we were specifying a line and a circle. So in this plot here, when we plotted our single variable, we were using data markers here as well. So that's the circles that we were plotting. Okay, so there's a whole range of data markers and line types that we can use inside of Matlab. So we'll go over a few of them right now. So call this data markers and line types. Okay, so we'll have an X domain from 0 to 10. And then we'll have some function. In this case, I'll call it A. And then we'll do 5 times x to the third. So we have 5 times x. I should be able to just do 5 times x and then to the third. Okay. And then we can plot this right now. So we're going to plot x comma a. So if I just make this plot, okay, let's get rid of our subplots here. And I'll comment that out too. Okay, so if I just do plot x comma a, then we have this pretty boring plot. So that works though. Just a kind of a regular plot that we've been doing throughout the class so far. I'll add a legend as well. So here I'm using the $sign because I'm going to input this this text as LaTeX syntax. If you remember doing this a while ago. Then I'm going to put interpreter LaTeX. So you don't have to do this, but I think it does look better. And okay. So run that. Now we see our legend up top here. Okay, so we can add some data markers to kind of change what this looks like. I should make this 0. In our step size, I'm going to put 0.1. Actually, I have 1. Okay. This will be better to kind of to show what we're doing here. So here's our plot. So in here, there's only there's 11 data points here because I'm going from 0 to 10 with a step size of 1. So like I talked about before, we're using this solid line here. And it's kind of being a little misleading because it's implying that we have more data than we really have. If we had a lot of data points like 0.01, then we could use a solid line, but we don't really have all of that data. What's the command to convert code to a comment? So you should just highlight all of the code and then press Control R. It might be different on your setup. And then to uncomment it all, you highlight it and then do Control T. I'm going to put in the chat too. Okay, thank you, Karen, too, for the Mac. Command / So, okay, I use my MacBook sometimes, and I've never bothered to look it up, but it always annoys me when I can't do Control R. All right, so let's do some data markers for this plot. So again, like I was saying, if we do a solid line here, it's not entirely, I guess, truthful or representative of our data because we only have 11 data points. If we had a more complex plot here, like a sine wave, that would be, an even bigger issue because it wouldn't be, we have a lot of curves, so we need to have a lot of data points to really represent that sine curve. Okay, so now we're gonna use a data marker instead of a solid line. So we're gonna use circles in this case. So I'm gonna have another argument here. I'm gonna put it in apostrophes. So inside of our apostrophes here, I'm gonna put a lowercase o, and that's gonna stand for a circle. So if I plot that, then now we have this plot here, which shows all of our 11 data points as a circle. Okay, and before, when I plotted our single variable here, I'm going to uncomment that. I'll call that figure 1. Now I need to call this figure 2. Okay, there we go. So earlier on, when we plotted our one variable here, if I change that to only have data markers, so I'm going to put just BO, that'll be blue circles. This is basically like a scatter plot now. So in this case, it's not representative really of where in this case, our function, if we had a function, where it's going. So that's why sometimes we would want to put a line as well. And in this way, we can kind of get a better sense of if we had a function that we are plotting, how the function looks. So sometimes you might want to have data points or data markers like a circle, but you'll also want to connect it with a line. So that's why you will use B, that just stands for blue, O, that stands for our circle data markers here, and then the dash line, that's or the dash, that stands for a solid line. So let's go back down here, comment that out. Okay, so I can add that solid line here by again just putting a dash, and then if I run the code, now our plot has our circles and it also has that solid line. Okay, and then I have a nice little convenient slide here. This is from the book for different data markers and colors inside of Matlab and line types. So we can go over some of these right now. So I'll just change our plot basically. So I can, instead of using a circle, I can use a square. So that'll just be an S. And then if I run the code, now we have squares instead of circles. We could do a cross, that's an X. I can change this to M for magenta. And now we have a magenta, X's, and a line. Let's do just MX here. So that'll be our magenta line. And then if I do B dash, no, that doesn't work. Okay. So I was gonna try to do a way where we could plot basically where we have magenta crosses here and a blue line. We can do that, but we'd have to make then 2 plots. Okay, so Karen, that's the same question that you have right now. Is it possible to make the line one color and the circles another? So yeah, so we can do that, but we have to make 2 different plots. So let's do that right now. So we run this code right now. All we have are pink kind of crosses here. So if I want to have also a blue solid line, I'm going to have to make another plot. So I'm going to say, hold on. I'll do plot x comma a, and then I'll do a b dash, or I can just do b, and that'll be a blue solid line. And there we go. So now we have our pink kind of crosses here and a blue line. Let's change this to, I don't know, we'll put a circle again. There you go. And there's also a way in Matlab to make the circle filled. So I didn't even see this until recently, so I might forget it off the top of my head. Yeah, I forget it. Yeah, you can do the O and the dash, but then that'll be the same color. So again, yeah, there's a way to have a filled circle as well, but I forget it off the top of my head. Something to do with filled though. So if you want a solid circle, you can look that up and then you can plot that.
Why don't you need a B dash for the lines?
By default, Matlab uses a solid line. So yeah, B or B dash, that's the same. That's just because, again, Matlab by default, they use a solid line.
So would you ever really need to put the dash, or just sometimes?
If you want to have kind of like one of the comments, if you want to have on, let's comment this out here. So right here, if I just have MO, then all we have right now are the circles. But if I wanted to have a solid line as well, then I would also need to specify that dash. But if you just wanted just a solid line, then you don't have to specify the dash. You could just have M.
Okay, thank you.
Okay, and then we have our different line types. So let's do some of those right now. So instead of a dash, which again, that's a solid line, if I do dash dash, now that's going to be a dashed line. Then we can also do a dash dot. And maybe a little hard to see right now, but that's a dash dot line. Yeah, I maybe need to make that a bit bigger. Or the line width, I should make that thicker. Or we can do a dotted line, which will be specified by a colon. And yeah, that's pretty thin. So let's change the line width here. We'll make that 3. And then there's our dotted line. It looks pretty terrible right now because on Linux, the graphics, like in real time, they don't look very good. But if I was going to save this plot and then look at it later, they would be a dotted line, not this kind of square. Okay, and then colors. So Matlab here, you can specify a color like we've been doing by using just a letter. So if I want black, that's K. By default, Matlab uses blue. So if I just have, X comma A, and I made that plot, then by default, Matlab has a blue solid line. So if you don't want that though, if you want maybe black, you're gonna specify K. So in quotes or in apostrophes, we're gonna put K. Now we have a black line. I could do R for red. I could do C for cyan, G for green. What else we got? We have yellow. Never use yellow unless you have a dark background. So those are all of the colors that we can do. Or if you really hate life, you could put a W for white, and then we can't even see it. So those are all of the colors that we can specify by using a letter, but we can also use different colors as well, where you have like an RGB value, but for that, you have to specify that a bit different, and I don't even remember it off the top of my head. So let's search it up. Matlab, RGB, color. That should work just like that. Okay, so yeah, we could change our RGB value here inside of brackets. So I don't do this pretty much ever, but we could try this right now. So we're gonna have to add some more code. So you could do that, but typically we're just gonna add just a letter to specify the color. All right. So you could take a look at this. I don't think we're actually going to do it right now just because I want to get through some more slides, but you can have a custom color if you want, but in that case, you'll have to specify the RGB value or maybe even the hex code. If you look that up, I'm sure there's a way to do that as well. Okay, so here's an exercise I'm going to have you do. So take these two equations, plot both of them. We're going to plot them on the same graph and have cyan solid line with square data markers for our first plot here. And then on the second plot, have a magenta dotted line with circle markers, circle data markers. I can't show you both slides at once. Actually, I guess I can. Hold on, I'll get the other slide popped up here. Put this over here. Okay. There you go. You might want to see both of these slides. So again, we're going to plot these two different functions here, A and B, on the same graph. And we're going to use different data markers and line types for each plot. All right, so I'll give you a few minutes to work on that. All right, I'll give you maybe one more minute. Okay, so I'm going to go over it now. So let's move this back. Okay, so we have two functions here, A and B. on a domain from 0 to 10. So we'll do x equals 0, a step size of 0.5 to 10. A equals 5 times cosine of 2 times x. So in this case, I'm not doing element by element multiplication because all I have is a scalar. I'm multiplying these by a scalar. So I don't have to do that explicitly. Then we have 5, b equals 3 times cosine of 3 times x. And then we're going to make our plots here. So we're going to have a plot. So we're going to use a cyan solid line with a square data marker. So we have plot x comma a. Then I need to have cyan, a solid line, so I can just leave it like this, or I could put a dash there for a solid line. So we want square data marker, so I actually have to do CS and then a dash. So if I plot this right now, then we have our cyan line and then our squares. So I think you have to do an S and then a dash. If I do it like this, okay, no, that still does work. Okay. Okay, so I also want to have the other plot here. So I'll do hold on. So that'll allow us to have the other plot on the same graph. So hold on and then plot x comma b. And here we want a magenta dotted line with circle data markers. So we'll do M for magenta, and we want a dotted line, so that'll be a colon. And then we want a circle data marker, so that'll be, an O. That'll be an O here. I'm going to do MO and then our colon operator. So usually when I plot stuff, I do the color and then the data marker that I have. So the data marker and then the line type. That's usually how I do it, but I guess the order doesn't matter. All right, and then we have our two plots here. So we have one with that's cyan with our solid line with square data markers. And the other is magenta with a dotted line with circle data markers. In this case, they're pretty thin. I always feel like the default line thickness is too thin. So I'm going to change the line width to 2. So line width, comma 2. And then if I run it, then that looks a bit better to me. Again, if I actually exported this figure, it would look better than it shows up right now. All right, we got 10 more minutes.
Does the order matter with like the O and the dots or the S and the dash?
I thought it did before, but it looks like it actually doesn't. So if I switch those, put O here. Yeah, so it doesn't matter. So it can still run okay. Let's see if I change the color.
Yeah.
I don't know if that's going to work now. Oh, no, it still does.
Professor, so it wouldn't matter if you put hold off after you plotted the second plot, or?
No, it'd be the same. In fact, we actually really should put hold off once we're done. That's kind of the correct convention to do that.
Professor,
Mm-hmm.
my plot is extremely zoomed out for some reason.
I don't know, maybe you accidentally went on the scroll wheel. I don't know. Because yeah, it should automatically have the axis fit to the data that you plotted.
Oh, I see why I left a plot on.
Oh, okay.
Oops.
All right, let's see what else we got here. So in our example here, I added a legend. We already went over that before, so we don't have to go over that right now. Okay, labeling curves and data. All right, so we can label some of our curves inside of Matlab. So kind of like I have here. So here I'm labeling these two different functions that we plotted. One is 3 times cosine of 3 times x, and the other is 5 times cosine of 2 times x. And that's what we just plotted. So we can add these labels inside of Matlab. Okay. Right. I guess I didn't make a plot where I actually showed how to add a label. Oh, yeah, right here. Okay. So to add a label, we're going to type in gtext, and that's going to allow us to place a label interactively on the screen. So if I go down here and I type in gtext, then I have to put whatever word or whatever function that I want to write inside of quotes once again. So I can do 5 times cosine of 2x. And now if I run our code, here's our plot. And you'll see once I go over the plot, I have this kind of crosshair that shows up. So I haven't touched anything right now. Well, once you press anything on your keyboard or you left click on your mouse, it's going to drop down that text. So I didn't mean to do that. Let's run that again. Okay. So I can place this plot now, or this this label anywhere I want on the screen. So I could put it right up here, and there's 5 times cosine of 2x. All right, and then I can add the other label as well. I'll just type in gtext, and then that's 3 times cosine of 3x. So now I'm going to run this again. So I'm going to put the first one down. So the first line that we typed out here was for 5 times cosine of 2 times x. So that should be the first one that we place on here. So I'll click. There's 5 times cosine of 2 times x. Oh, I didn't type gtext. That's why. Okay, I'll run it. There's the first one. And then you'll see that I have the crosshair that shows up again. So I can place the second one. And then I'll just click down and there's the second. So, we wouldn't usually use a label for plotting these functions like we have right now. Instead, we would use a legend, but sometimes you want to point out something that's unique in your data set or for whatever you're plotting. So if there's some point of interest in your plot and you want to specify that or kind of show that off, you would want to use a label. So, for our project, for COVID, let's say there's a spike after Labor Day, right? If there's a spike in cases after Labor Day, then you could use this option here where you could make a label and you could kind of show that on your plot. I don't know if there was or not, but if there's something like that, you could do that. So it's useful for some of the plots that we have. All right, so we could place it interactively, or we could specify just through code where we want to have our label. So if I wanted to have, and this might take some kind of guess and check right here, if you want to specify it by code. So if I instead do text, then I have to specify the X location and then the Y location. So let's do X, we'll put 4. So this is to specify 3 times cosine of X. So I'll do 4, and then I'll do, hold on, I forgot which one is which already. Okay. So yeah, I'll do 4, and then I'll do like 3 for the Y value here, and then I'll put in our string, 3 times cosine of 3x. So first I have to specify our interactive one. So that's, I think I flipped them. Yeah, I did, but oh well. So you saw the other one, it showed up right away. And that corresponds to this line of code right here, where I typed in text, put in the X value, put in the Y value, and then you put in the whatever string that you want to type. So in this case, I had 3 times cosine of 3x. Okay, Yeah, okay, whatever. But in general, we don't really want to use a label to point out the curves that we're using. Instead, we'd use a legend. So you can change the color as well. I guess I didn't show it. We should just be able to specify the color right here, though. So if I do cyan, let's try that. Did it work? Didn't work. Why didn't I show the code for that? Okay, so I guess I didn't show the code, and I can't remember off the top of my head on how to specify the color there. Or oh wait, I think I might remember right now. If I do cyan, is that gonna work? Nope. Okay, I can check my scripts over here, and then I can show you guys. I'll maybe put it on a canvas, but I forget how to specify the text color off the top of my head. We might need to specify something like text color, and then comma cyan. Nope, still didn't work. Okay, so I'll look that up after class. Class is about to end anyways. Maybe it's in this one here. All right, guess not. All right, so I'll check that and I'll put that on basically on our page for this week for Canvas, and then I'll show you how to change the text color as well. But that'll be something that's pretty simple. I think we have to specify something like I just did, but I forget the exact argument, but it might be something like where you say text color and then you specify whatever the color is. Okay, let's see. What's the next slide? Okay, so we'll get to this next time, tick values and labels. This will be another important thing for the project. You know what we'll be doing in the project? We'll be plotting like COVID cases. So on our x-axis, we'll have the date. And then on the y-axis, it'll be like, you know, the cases that we have or the amount of deaths, something like that. So by default, our x-axis often, you know, that's set automatically for the amount of tick values that we have. So if we're doing it by month or something, it might only show a few months on that axis. So we need a way to change it to show every month. So we need to specify that ourselves. So there's a code that we can do to specify the amount of tick values that we have. And then also the tick label that we have. So you see on this example here, I'm actually using the symbol for pi. So we can do that as well. But we're out of time now. So again, I'll check on how to specify the text color as well. And I'll put that on the page for this week in Canvas. All right, so if you have any questions, you can stay after class right now. But if not, then I'll see you guys this Wednesday.
Thank you, Professor. Have a good day.
Thanks, you too.
I have a question about the text.
Okay.
Is it like, okay, like text and then with 4,3, is that like to place it in that exact spot on the graph?
Yeah. And
Okay.
I think they define it where it's starting on the left, the value of whatever your text is. So, you know, it's not centered, but 4,3, that would correspond to like the beginning of 5 times cosine of 2x. Like right there.
Okay. Is there also like a way to center it or no?
I don't think so. You just have to change your x value and your y value a bit. So there's kind of some guess and check for that.
Okay, thank you.
Mm-hmm.
Professor, when I was doing the plotting like a while back, it came up with an orange thing that says warning, a colon, and the warning extra legend entries. Do you want me to show you share my screen? You can see it.
Sure. Yeah, it sounds like